Assalamu alaikum. Hey guys, I'm back and welcome all of you to my new video tutorial. This is another video tutorial on Google Earth Engine, and today's topic is all about supervised classification. So for this tutorial we're gonna use a smile curve machine learning algorithm developed by Bremen et al. In 1984. This is available in Google Earth Engine. You can use freely, no problem. So for this tutorial, the codes needed or necessary for this classification might seem to be a little bit daunting and scary because it's a bit longer. But to make this this code easier and accessible to you, I have already written this and I will explain it just bit by bit and run the code eventually to get our desired result. So without further delay, let's just jump into our tutorial. First thing that we need to ensure is creating training data. So you can collect your training data either by using geometry drawing tool existing in Google Earth Engine, or you can also upload some predefined training data set through Google Earth Engine's assets section. For this tutorial, I will be using the former one. Training data will be collected by using geometric tool. So let's just show you how to get started with that. So there are a bunch of geometric tool, drawing tool here. This is the point drawing tool and line and polygon, and this is rectangular. So the study area for this tutorial I have selected is the Everglade wetland. Everglade wetland is a very diverse and dynamic ecosystem location located in Florida. First I need to collect some sample data. Based on that, smile curve machine learning algorithm will classify the whole study area, categorizing some sort of land cover, like water bodies, vegetation, like barren land, build-up area. So many categories we can adapt, we can create. So let me show you how to collect the training data using geometric tool, geometry drawing tool in Google Earth Engine. So to accomplish this task, you need to click first this location icon. Then you will go to the settings. Here you will specify some properties. So the first land cover we're gonna assign as water body, so name it water. Import as, we're going to import as feature collection, and expand the property, go to property, and then all the land cover will be jotted together as a common name, and that name, let's call it class, and the class value should be different based on the land feature. Like for water bodies, let's assign 0. For like barren, we will assign 1, and so on. So click OK. Once you click OK, come back here and see that there is a geometry imports created called water. Now you will just click this, and randomly from your own observation, you will just select or collect some water bodies. So we know that the deep blue a black kind of thing is I mean water body signature. So let's collect some random water bodies sample point from here. You can collect from different areas. Let's see, collect here from, okay, so I have just collected 11 points for water bodies. You will collect as many as possible, but not too much. If you just assign so many points for a particular land use, sometimes Google Earth Engine shows the computational error. I mean the sensitivity and uncertainty model works there. So now let's create another geometry input. Go to the settings and name here barren this time. As usual, feature collection, go to property and name it as the earlier one class, and this time the class value should be different, and that should be 1 for me. You can just name it differently, however keep the sequence. Then we can also create some other value, class value, like let's say name it vegetation feature collection class and 2. Sorry, vegetation class 2. Okay, so I have just taken 3 land cover. For your case, you will take as many as possible as you consider. So let's pick up some a barren point. So here the barren point, like this. How you will get to know that this the points you are collecting are assigned for barren? Based on the color. Look, this is the same color assigned for barren and also for my points. So now let's go to the vegetation point. Vegetation is colored as red, so vegetation, let's collect some vegetated area point here. Okay, so I'm not gonna collect so many points. Even I'm not gonna use this point as well for this tutorial. I have already collected some points for a particular land use, land cover that I will be using for my, but I have shown this because you should know how to collect these sample points, the procedure, and how to just name it, properties, etc. So one thing you should have noticed in the meantime, that once you save it, you finished off your geometry input, automatically Google Earth Engine has detected and imported all those land feature points into its code editor. So you don't need to be bothered where it's gone and how to just drag into your code editor. You don't need to be bothered. Google Earth Engine will do it for you. So this is how you can collect your sample data. So once you have done collecting your sample data, you should start writing your code. So for coding, for writing the codes, I have already another code editor. So let's switch over on that code editor. Look, here are my sample points for a particular land cover that I have already collected. So I will be using these data sets, sample data sets for my classification. So let's just, show you. I have categorized my prospective land classification into basically 6 categories. So from 6 categories, I have collected sample points. One is the deep water. For deep water, I have 687 sample points. For moisture soil, it's 284, vegetated area 310, 383 points. For shallow water, dry soil, artificial surface, build-up area, all these things I have already collected, so I don't need to spend any more time on collection. Simple sample point collection. So now let's just jump into writing the codes. So first part of the code is let's copy and paste, is the selecting the study area. So what I have done in this code, let me just briefly explain. First, with these 6 categories, I have also uploaded a shape file called Everglade, which will define my study area. So for that, you also need to upload a shape file, or you can also use the geometry manually, but that takes time. So I have uploaded my shape file as the boundary for my study area, which I have used in my selecting study area code section. So first, I have declared a variable called Landsat8, because for this classification I will be using Landsat8 data, tier 1 and top of atmospheric data. So the variable here is declared as Landsat8, and I have used the image collection function. Under image collection, I have put the image directory. Then I have worked with filter bound, study area boundary I have selected. Here I use the function called filter bound, and filter date. This classification will be based on from the year 2013 to 2021. So I have just specified the date. And filter metadata, it works basically on image visibility, whether how much cloud cover you would allow or not. So for me, I have just specified allowed the image to be imported less than 1 cloud coverage. Then I have used mean image. There are many images, so I have just, it's optional. You can also ignore it or just escape it. Then I use the cliff function, which is very, very important. What we did in ArcGIS, well, raster classification, raster clipping. So for raster clipping, we used, could you remember, just verify it with your concept. We used either a shape file or a raster, a vector or raster to clip a particular image over our study area. So here we are using the shape file as the clip feature, and our input feature is the image, like this one. So By using this function, we are indicating that we are telling Google Earth Engine that Google Earth Engine, you should summarize or clip the Landsat image over my study area, that is Everglade. And then I have used map.center object function, which is nothing but where my output map or output classification should be centered in this map, Google Earth engine here. Now I have used map.addLayer. It basically displays the output map. So here I have specified the band name of this image. So there are mainly two color bands, B4, B3 and B2. If I run the code, let's see. It takes time. Look, there is an output over there, but it's not a final one. So bit by bit we will go ahead. Okay, now let's head over to the next section of this code. Let me just copy and paste here. This part of code will be working on merging all these sample point together, and it's gonna work as a combined sample point. So for that I have used merge function, and I just jotted all this 6 sample point together. Now then I have declared another 3 variables, which are label, bands and input. Label variable is based on the class, and class is nothing but the properties from the image geometry. Look, all the land class has the same property called class. So this is that class assigned for variable called label. And variable bands is nothing but the band combination, which band we are gonna consider. For this section, we just reversed. We use in this part as true color, but here we'll be using false color combination for the image to be visualized, to displayed. Here we added one new band called B6, which is designated for shortwave infrared 1 for this Landsat image. And all of you know that the RGB combination, band 4 for red, and band 3 for green, and B4 is for blue. And the input variable, which is declared and assigned to Landsat8, the earlier variable, and it will be selecting the bands, which is basically this one. So this is all about merging training data. If I run the code, there shouldn't be significant change, because we have not reached destination. Once we will reach the conclusion of this code, then we are expecting to see the significant change of this code as a result. Now let's head over to the next section of this code, which will be working on overlaying the training sample point over our image. The most important function we're gonna use in this part is sample region. Sample region is a function which converts each pixel of an image at a given scale, obviously, that intersects one or more regions to a feature, and eventually it returns them as a feature collection. So here there are some parameters we should just set them determine, like collection, properties, and scale. These are mandatory. We should just define. There are other variables, parameters, which are optional, like projection, like tile scale, something like that. So here, as for collection parameter, we have set up training a variable from this section, and properties label from here, and scale we determine as 30. Then we have declared some more variables. For this section, we have to understand very clearly, more specifically for this two train set and test data set variable. How does it work? So let's just dig it up. Variable training data is based on train image. Where does it come from? Train image comes from this overlaying section. Here we have used a random column function, which basically assigns for points, sample point, some numerical values based on either unary system or binary system. Once this is done by random column function, we're gonna head over to filter function to filter out all this training sample data into two categories. So the task of random column, as I have already said, that it adds a column of deterministic numbers, numerical or pseudo random numbers to a feature collections, and the outputs are double precision floating point numbers. So when it's done with that, we can see that the numbers will be disseminated over all the sample data. And one very important thing that you should know, after that, the whole sampling data will be divided into two pairs. One is less than 0.8%, and the other one is greater than or equal to 0.8%, 0.8 or 80% or over 80%. What does it mean? To make it clear, variable train set will sort out all the data from sample point, which will account for less than 80% of total data, and variable test set which will be accounting for as a whole 20% data, and that 20% data will be collected from over 80% of total data. So this is a complex a process of thinking, but it's now clear, I would say. So if I just run the code till now, let's see what comes up as the result. Okay, let me just get rid of all this sample point, because we no longer need this point. Okay, so we got rid of the sample points right now. Okay, Now let's go ahead to the next section of this code, which is classification model. So let me just copy and paste here. The first section is classification model. We have to determine, we have to specify what type of classifier we're gonna use for this classification. As I have already mentioned that this classification will be based on machine learning algorithm, a classification from it called Smile-Curd, which is basically regression classification model and developed by a couple of scientists and led by Leo Breiman in 1984. So here we have declared another variable called classifier. Under classifier we have used ee.classifier function, and then we used the Smile-Curd classifier, which is existing in Google Earth Engine. Then we're going to train this classifier, so that we have used train function. Under train function, the parameters we have set, the first parameter we have set is this one. Okay, as we have already said that 80% of all the total data sample will be used as for the classification purpose. That's why we use that variable as train set. Then we just specify the label, what type of categories, how many categories we want to be classified. So here that is the common classification class, that is class here, and bands combination we have declared here. I have just dragged here. So this is classification model. We have a Smile-Curd, we have classifier, and we have train set data. Based on this, Smile-Curd will be classifying. Then the second part of this section is classify the image. So once we have set up or determined the classifier, we need to just classify. So the final variable, which is classified, under input.classify.classifier. So here is the classifier. I just inserted that classifier as a parameter for my classification. Okay, now if I run the code, let's see if there are any changes comes up. Okay, yes, there must be changes, but we cannot detect it in our naked eye unless the final result. Okay, now the final part of this code is defining the color palette. Okay, the fundamental theoretical things we have already set up. However, the last part, this part will basically determine how the result should be looking like, how it should be visualized. So these are the codes which are nothing but the ornamental stuff. So define the color palette. So here we have declared a new variable called land cover palette. Land cover palette, look, this is the deep water, which is as 0 for property value, classification value, shallow water 1, moisture soil 2, vegetated area 3, and dry soil 4, and artificial surface 5. So each classification our land cover should have assigned a definite color. So these are HTML color scheme. If you can just search in Google HTML color code, you can see here are the color code. So you can choose any of the color based on your choice to assign for the land cover. So I have just collected and assigned the HTML color code for each land cover. So you don't need to memorize and don't need to be daunted. Okay, now this part map.addLayer, remember once you have, let me just get rid of this. Try to remember that if you want to visualize your output map or image onto Google Earth Engine image viewer, you must need to use this map.addLayer, because map.addLayer functions basically on exporting your image on this map viewer. Not exporting, I mean that to display your result as an image on Google Earth Engine map viewer. So that's why we have eventually used map.addLayer. Here there are some parameters you should determine, you should set up or supply. The first one is classified.clip.everglades. So classified image, we have this variable and we are gonna use once again clip for our study area Everglade. Then we specified the image visualization parameters, that is palette, land cover palette, which here everything is specified which type of color to which type of land cover should be assigned. Then min 0 and max 5, and we name it as classification curve. So till this point our code looks fine. If we run finally and hit the run button, let's see what happens. It takes time. Look, this is the final result. Okay, so here if you just come back to the geometry imports, here blue designates the deep water, moisture soil is this color, and vegetated area is green, shallow water is sky color, something like that, and this is a dry soil purple, and artificial land is something called yellowish. So look, if we inspect it a little bit, we can see that this is the Everglade wetlands, and based on Smile-Kurt classifier, we have classified the whole study area either in deep water, shallow water, moisture soil, vegetated area, dry soil, or artificial surface. So based on this classification, we can see that there are dominant vegetated area and shallow water. So as this is a wetland, so water must be dominant, and also we have in this area a big part of vegetation. So that's how you can classify any area as long as you have this kind of code. And Google Earth Engine is a very cool platform. You don't need to download the image and extract it into your ArcGIS or QGIS, and then you will need to just spend time to classify it days after days. No, that time is over. Google Earth Engine has come up with this cool and very first idea. So that's all for the time being. I hope you guys have liked my video. If you have, please do subscribe to my channel. I'll come up with another new video. Till then, bye bye. Allah Hafiz.